Alright, so let's continue the practice questions for topic 4, capacitors. Question 15 is talking about the distance between the plates is reduced by a half and the area is doubled. What will happen? Just like in the previous video, I'm going to set everything to 1 except the thing I'm changing. The rule is C equals epsilon naught A over D. This is the formula. If I made everything 1 times 1 divided by 1, that will just give me 1. But what I'm going to do is I'm going to change the distance and I'm going to change the area, because what it says here is the distance is reduced by a half and the area is doubled. So C equals epsilon naught, I know it's 8.85, all of that, I'm just going to call it 1. Multiplied by the area, half doubled, I will call it 2. I'm going to divide that by, well, I'm going to divide that by a half. 2 divided by a half. Put that into your calculator, you should get 4. So that will be 4C. In this case, it will quadruple. So the best answer here, of course, is C. There we go. A parallel plate capacitor has this and this. It has a charge of Q. When the capacitor is connected, the distance is decreased. What's the magnitude of the charge on the plates and the capacitance? Okay, so basically what we're going to do is see what will change as a result. So what I've done is I have decreased the distance. So C equals 1 times 1 divided by 3, not 3, 1 over 3, because I've decreased it, so 1 over 3. That becomes 3C. So my capacitance has increased. That means if it's connected to the same voltage, I still have the V involved, which means I can do Q equals CV. Now, the V is there, but I have now increased my capacitance, which means I can actually, if I increase my capacitance to 3, my Q will also become 3. I can call it 3Q. It will become 3Q because I have increased my C by 3, and this will increase by 3 as well by using the same idea basically. C can be 3, keep the V as constant as 1, that becomes 3. Q equals 3. That's how I did it. Alright, so that means C is good over here. Potential drop for a circuit, so the V for a circuit with 3 capacitors of individual capacitance in series is what? So in this case, you're just basically comparing the voltage for each capacitor. As you know, in a series circuit, you will have 1, maybe 2, and maybe 3, and they have different values. And let's say I had, I don't know, 10 volts from the battery. Some of it will come here, some of it here, and some of it here. The voltage will split according to the capacitance. Q equals CV, again, rearranging. C equals Q over V is not what I'm looking for. I'm trying to find V. V equals Q over C. So now, looking at this, if I have a big capacitor, my V will be less. If I have a small capacitor, my V will be more, because it's going to be harder to hold the same amount of charge on a small capacitor. There's not enough space. There will be more repelling from the electrons. If this capacitor was big, the electrons are comfortable. They can sit there nicely. You do not need a lot of energy. But if my capacitor was small, very small, and you want the same number of electrons on it, because remember, charge is the same in a series, I will need a bigger voltage to hold them in place because the capacitor is smaller. So that's a way to understand why. So it's largest across the smallest capacitor. So the best answer here would just directly be C. Alright, capacitors in series have the same, I kind of just gave it away, it's the same charge in capacitance. So the Q, whenever you calculate it, is the same in series. In parallel, and again, it's the opposite. If I was to add another branch with another set of capacitors, it doesn't matter, this 10 volts going to each electron will also come to here as well. The electrons, rather than taking this path, they decide to take this path instead, and they all have the same energy from the battery. You know, they haven't used it along this path. Instead, they use it along this path. So these two will share the voltage from the battery. So the idea is voltage in parallel stays the same, charge in series stay the same. Clearly, charge in parallel will split. According to this, it splits into 2 branches. So there we go. So what is the question even asking me? It has the same potential difference, that's the idea, the same voltage as I just explained. If you have a number of identical capacitors in series, there is actually an easy way for you to do it. You just take the value of the capacitance and you divide it by the number of capacitors. So the answer is, in this case, going to be A, but let's understand why. If I had two capacitors in series and both of them had, I don't know, two capacitors and they both had, let's say, 10 farads each. Okay, two capacitors, 10 farads each. In series, the formula is 1 over C equals 1 over C1 plus 1 over C2. So I'll call this 1 over 2, not 1 over 2, it's 10 I chose, right? So 1 over 10 plus 1 over 10. That will give me 2 over 10. Of course, that's for 1 over C. If I want C, I will flip both sides. Becoming C over 1 just becomes C. And 10 over 2, what does that become? It becomes 5. It became 5. So basically C over N, 10 divided by how many capacitors? 2. 10 divided by 2 is 5. This is a short way of me doing this. I'm literally just going to write 10 over 2. Now, what if I had 3 capacitors? Let's add a third capacitor. Let's do 1 over 10 again. Again, this only works for identical capacitors. So instead of that, I will have, in this case, 3. 1, 2, 3. 3 over 10. Flipping both sides, 10 over 3. 10 over 3 is whatever that is, like 3.33 or whatever it is, 3.33, something like that. So the idea is nice and simple. I can now just change that to 10 over 3. So this is how you can find it, all right? Nice and simple. But if they're in parallel, we already know it's C1 plus C2 plus C3 and so on, and you will get the answer. Or if I have 3, 4, 5, I can just multiply it by 2, 3, 4, 5. So for example, if I had 10 plus 10, obviously that is 20. Nothing hard there, and I still got it wrong. I wrote 10 again. Oh my God, as easy as you think it is, you can still make mistakes. All right, C1 plus C2 is 20, or I could write C multiplied by how many capacitors I have, 2 of them, so I will get 20 anyway, right? 10 times 2 is 20. If I did 3, 10 times 3 will be 30, 10 times 4 will be 40 because there's 4 capacitors. So the C multiplied by the number. So the number multiplied by C is the same thing. So I will pick D for this one if it was in parallel. So I've just spent a long time explaining something really simple. I'll try to be quicker with the next questions. C over N, N times C. Done. Okay, let's move on. Right, question 22. Over here, the total capacitance in series, if you noticed that it reduces. If I keep adding a capacitor, my capacitance gets less. So, an actual interesting trick is, it's always smaller than the smallest value. If I had a capacitor of 100, and then I had one which was a 50, and that's, what the heck is that? 50, and then I had one 2. 3 in series. My total capacitance, believe it or not, will be smaller than 2. It'll be less than that, even though we have these big ones here. So it's smaller than the smallest capacitor. It's a little trick there. So if you're solving a question and you get an answer, and your answer happens to be bigger than 2, you know you've made a mistake somewhere. It should have been smaller than 2. Then you know you're probably right with your answer. In series, which is the equivalent capacitance for this one, like we just mentioned in the previous on the previous page, you will become C over 3. Literally, that's exactly what I just did over here. I did 3 of them together, becomes 10 over 3. 10 over 3. I use the number 10, but C over N. C over 3. So C over 3. Where is the option? 3 over... there we go. C over 3. Over here, what is the equivalent? So again, next time is Cn. You multiply by the number. So this is 3 of them, so that will become 3C. Over here, you need to find the capacitance or the charge on capacitance C. Now, I made a video which actually looks very similar to this one, solving a full question on capacitance in a circuit. I suggest watching that for a full explanation of what we're just about to do now. In order for me to find the charge here, this is the same charge passing through the battery. So I need to find the Q total. I need to find Q total. That will be C total multiplied by V total. Okay, I have to calculate the values of the capacitance first. These two are in parallel, which is in series with this one. I can quickly find these two, and what we can do is these are all 10. No problem. So this is in parallel, so 10 plus 10 is 20. This is also 10. So C parallel becomes 20 farads, or microfarads, I should say, plus this one in series. The rule for series, you have to do the 1 over formula. So you can quickly find this here. You can find the C total by just doing 1 over 20, because that's all 20. If I replace this with one capacitor, it will be 20, plus 1 over 10. And if you want to directly get the answer, you can just put this in your calculator like this, to the power of -1. You solve that, the calculator will tell you the value for the C total. That will give you the C total. Unfortunately, I do not have my calculator handy, so you're going to have to stick with me as it is. So once you've done that, then you just place that into this formula here. You multiply that by the voltage. You multiply that by the voltage, which is 10. So I'm assuming that the capacitance will be 6.66. If I do this, this will become 6.66 based on deductive reasoning. I'll round it to 7. Multiply that by 10 will give me 66. So this will become literally 6.67 times 10, and because the V is 10, that will give me the answer of 66.7. So the answer would have been A. There we go. Easy, I hope. Let's move on. The 3 capacitors, 1, 2, and 3, are connected in series with the battery. What is the voltage across this individual one? Okay, so there are actually multiple ways to do it, in fact. But if they're in series, an easy way to just quickly solve this, we can just calculate the total capacitance, find the total charge. Once we've done that, we can just find the V on any of the capacitors. What am I talking about? Here is my battery, and this is 13 volts. I can calculate each one. So what I'm going to do, this is the first one, and then this is the second one, and this is the third one. Over here, this is the third one. I tried twice to fix that line. I failed both times. Okay, here we go. So now we have 4 micro, we have 6 micro, and we have 8 micro. And we don't know the total charge yet. The idea is, if I find my C total first, C total equals 1 over 4. I'll make this in a little bracket to get the answer directly, plus, that's a 4, 1 over 6 plus 1 over 8 in brackets to the power of -1. Putting that into your calculator, you should hopefully get, I'm hoping this is right, you will get something like 24, not 24, I think 24, you know what, I should probably check, right? I'm going to actually, I've got my calculator right here, what am I doing? Forgive me, so let me just quickly do this. Let's do this. So, in a bracket, 1 over 4 plus 1 over 6. 1 over 6. Let's do that now. Why is that not deleting? Go away. Thank you. 1 over 6 plus 1 over 8. Plus 1 over 8. In that bracket, I am going to do the power of -1, and I will get my answer of 1.84. I knew I would have been wrong, because how I was going to get 24? Where did that even come from? That was too silly of me. 1.84. That's more accurate. Why did I start with that? Try that again. 1.85. I'll round it up. Okay, that's the total capacitance, microfarads. Okay, I can find the charge, Q equals CV. I can quickly find the charge. I will do 1.85, and I'm going to multiply that by the voltage, which is 13. 1.85 times 13, I will get 24. This is where the 24 comes from. 24, I remember solving it earlier. 24 coulombs of charge. Now that I know the charge and I know each capacitor, I can calculate the V for any of them. I can do V equals Q over C. The charge is the same. Q over C, and the charge is the same, so 24 divided by 8. If I'm doing 24 divided by 8, if I was to do 24 divided by 8, I would get 3 volts here. I can do it for the 6th one as well. In fact, that's the one that I'm looking for. V is Q, which is 24 over, not 24, yes, 24 over 6. 24 divided by 6 is 4. equals 4 volts. You can do the same thing here. But another thing you can do is, if I know this is 13, yeah? 13 minus 4 minus 3 should give me 6 volts. Let's check if I am correct. Let's see if my brain still works. This is extra by the way, V is Q over C. This is going to be Q, which is 24 divided by 6. 24 divided by 6 is wrong. Why is that wrong? Well, maybe my brain is not working. Oh, that's why it's wrong, because I wrote 6. It is not 6, this is 4. It's my fault for writing that too early. I got too excited. All right, 24 over 4. 24 over 4 is 6. There you go. I was right after all. Okay. Anyway, this is 6 volts plus 4 volts plus 3 volts equals 13 volts. So I'm telling you this because the question can ask anything. So I've just shown you how to solve for anything. The answer for this specific question is only this part here. All you had to do was find the total capacitance, find the total charge, and then V is Q over C. And there'll be 4 volts for this one here. So that would be A for this one. Okay. Moving down, so this is going to be the last one because the video is getting too long because I'm just taking too much time. What's happening here? This is the capacitance here. All right, so we have 2 branches. We have this branch and this branch. We know they're parallel. We know we add. So I'm going to add this with this. But we have 2 over here. So let me find the equivalent in this branch first. Once I find this total equivalent, then I can add it with this. There's only 1 on that side. So let's quickly find the left side. This is in series. So I will just do the rule C equals 1 over 2 plus 1 over 1 to the power of minus 1 plus 3. That's a short way of just getting the answer. If you did that correctly, hopefully you would get the answer of 3.67. 3.67. And I'm going to stop there.